In this video we are exploring two fundamental methods in LINQ, Count and LongCount. These methods are like the toolbox in your garage, essential for getting an accurate measure of what you have. In this case, they help us count the elements in a collection, much like how you might count the number of books on a shelf or the number of apples in a basket. Both Count and LongCount have two main ways to use them, or in other words, each method has two overloads. First, you can call them with empty parentheses like this. This is like asking, how many items are there in total? It gives you the total count of elements in your collection. Second, you can use these methods with a special condition inside the parentheses like this. This is more specific, like asking, how many books on my shelf are over 200 pages? You get the count of elements that meet the condition you set. Now, here's where they differ. Count is your go-to method for most collections, but it has a limit. It can only count up to int32.max value, which is a really big number, but not infinite. The result you get back is an int32, a standard integer. On the other hand, LongCount is like a heavy-duty tool for when you have a really large collection. Think of it like counting the number of stars in the night sky. There are so many. LongCount can handle these massive collections because it counts up to int64.max value, giving you a result in the long, or int64, format, which is even bigger than int32. So, in summary, count is great for most tasks, but when you're dealing with something huge, LongCount is your friend. Now, let's roll up our sleeves and see these methods in action with some practical LINQ queries. I have an array of integers. To find out how many elements it contains, we can use a simple LINQ query. By using the first overload of the count method, which doesn't require any parameters, we can easily determine the total number of items in the array. For example, as our array has 5 items, the count method will return 5. Now, let's consider a list of fruit names. If we apply the same count method without any additional parameters, it will tell us the total number of fruits in our list. For instance, our list contains 7 different fruit names, therefore the result of the query will be 7. But what if we want to count only the fruits that start with the letter A? This is where the second overload of the count method comes into play. By adding a lambda expression, we can specify a condition. In this case, our condition is to count only those fruit names that start with A. The count method will then return the number of elements that meet this condition. As you can see, our list has 4 fruits that start with A, so the result of this query will be 4. This is a practical example of how to use the second overload of the count method, where we apply a specific condition to our count. Alternatively, we can use the following query to get the same result. Here the where method is used to filter the list. This returns only the fruit names that start with letter A. Then using the first overload of count method we will get 4 as result. Let's delve into an example using a data table with name and age columns. Imagine we want to count how many adults are in this table. In other words, we're interested in the number of people whose age is 18 or older. To do this, we will use the count method's second overload, which allows us to specify a condition. Here's our approach. We examine the age column in each row to check if the age is 18 or greater. The result of this operation will be the total count of rows that satisfy our condition, effectively giving us the number of adults in the data table. In another scenario, let's see how we can use the count method within a query, not just to count items but to filter data. Consider we have a data table with columns ID and category. Our goal is to group the rows by their category and then only keep the groups that contain more than 2 rows. Here's how we achieve this. First, we group the rows based on the category. We then apply a filter using the where clause. In this step, the count method comes into play to check the number of elements in each group. Next, we iterate over the rows in each qualifying group with a second from clause. The select clause is then used to pick the rows from the groups that meet our criteria. Finally, we use copy to data table to transform our query results back into a data table. This process demonstrates a sophisticated use of the count method, where it's integral to filtering and shaping our data within a LINQ query. In the examples we have explored, I use the count method, but you can achieve the same results with the LongCount method as well. However, remember what we discussed at the beginning. LongCount is particularly useful for extremely large collections, where the number of elements might exceed the maximum value an int32 can hold. That's all you have to know about the first two aggregation methods, count and long count.